And let's see what it comes up looking like.
Can not see it?
That's the secret.
I got it recording.
Sorry, my friend. Here we go.
Some help with that donkey?
Yeah. I don't remember the rest, but your mother's a whore. Why is it shaking? All right, thank you.
The mayor, Huckleberry.
We good?
You know how to work that?
We good?
Good enough.
It smells like Bisquick and hot
Good?
berries.
Yeah. All right, let's go ahead. We'll do it live.
Do it live! Fuck it!
All right. Welcome. I'm going to try to keep this in the 15-minute time frame. It's not auto-advancing. This is another log to analyze, utilizing DNS logs, packet captures to discover malware within your unique environment. My name is Dave Marnier. I'm a senior computer network operator with telecommunication systems, specifically RF exploitation. I do instruction, and I also do pen testing on the side for them. I also do some work with package security, but it's not too important for this talk. So let's go ahead and keep rolling. All right, so we're going to talk about finding malware within your network utilizing your DNS logs or packet captures. So even though malware utilizes DNS logs, those logs are typically underutilized as a security asset. We're going to go ahead and discover, or try to talk about how we can go ahead and discover malware in our network through talking about establishing DNS query and response baselines. That's going to be a topic that's going to be very important. We need to know what is normal for your particular environment. Everything is going to fluctuate for your own unique environment. So we have to have a baseline for that. We also need to have analyze NX domain responses. Advancing on. NX domain responses are basically when you factor in something that comes back and says, I cannot resolve that query for you. We're going to talk about that query here in a second. We also need to analyze the successful DNS queries that go out. So what are my users querying and where are they going on to on the world of the internet? And specifically, once we find that, we need to identify domain name anomalies or something that's suspicious within our user environment. So we need to have a traffic baseline. So we need to have that normal to compare everything else to contrast with apples and oranges. So we need to know what's normal, specifically the top level domains, or TLDs for short, and also second level domains. So the .coms for TLDs, the Google.coms for second level domains as well. We also need to know which hosts and servers are doing that as well. So what's normal for our unique environment? Who is going where? Who is querying out to the internet and where are they going to? What's normal for an everyday, month, day, hourly, weekly, monthly type of thing? And also, who is my top DNS queries? Where are they going out to? Per host, network, domain, or site, if you can get that granular. What is normal also for your HR department? It's going to vary greatly for your IT department, right, your security folks. And also, specifically, what is normal for your time of day usage? So 8 to 5, I know I'm going to have a high spike of bandwidth, and also, at 2 a.m., I'm expecting not even on my network, besides that people are working shifts. So you have to have that baseline to go and compare things to. Before we move on, we're going to talk about DGA, which is also known as the domain generation algorithm. Malware utilizes this to go ahead and contact its command and control service. So we're going to talk about DGA for short, C2 for short for command and control service. So DGA is basically an algorithm that the malware on your user environment or wherever it's infected on knows the algorithm, the command and control server knows it as well. They're going to go ahead and compute that. They're going to compute a list of candidate domain names, and let's say for ease of use, 10 particular domain names. 9 of those are going to fail, 1 of them is going to be successful, so the malware can communicate to the C2 server. Of those, we're going to go ahead and talk about the 9 that basically failed for us, and then it's going to indicate which host on our system is actually effective. Configure specifically utilizes this technique as well. It's being adopted by other malware as a backup strategy, and basically to get around the blacklisting for a static list of IP addresses that contact command and control servers. So, like I talked about before, NX domain responses are commonly a result of backfingering something. So, I type google.com with 3 O's. It comes back, I cannot resolve that because it's not a valid domain or a fully qualified domain, FQDN. That response there is going to get a NX domain response. It's not going to get the, okay, I resolved that name for you, it's good. It's going to get that NX domain response. It's going to be helpful for us when we're looking through our logs to see what's going on in our environment. Particularly also with DGA, like I just mentioned, let's say an example that 10 of them were, 10 candidate host names were launched, 9 of them failed, 9 of them are going to get NX domain responses, 1 is going to get a valid response. So we need to know what's normal for NX domain responses as well on our particular environment. And if you can get granular, hour, weekly, on down the line. So if your average NX domain response for your entire network is 25 roughly for your entire network, and then you see a spike of 50, or let's say 10 for one particular host on your network, well then that machine is probably affected because the amount of NX domain responses on the machine is too damn high, right? There's too many NX domain responses over my threshold of what's normal for my network. You guys like that meme? I try to come out a lot of memes, so I don't got a lot of time. All right, we also need a query for a lot of malicious domains, and this is the known bad, right? Not the unknown domains like Dr. Russell said. We need to look for the known bad, right? So let's go ahead and look for what's known that's bad. What hosts or what domains are already known to be hosting malware. So go ahead and take that information that's freely available to you on these resources from the community, such as malwaredomains.com or malwaredomainlist.com. Look for that in your particular environment. If you see something, that's probably abnormal. Identify that machine, take it offline, reimage it 18 times. Take it off your network, burn it with fire. All right, we also need to analyze the DNS traffic as well. So there's going to be a lot of information here. Specifically, we're doing a packet capture. There's going to be way too many packets. It's going to be information overload. You're going to spend way more time analyzing things than you will be collecting those things because it happens like that, and analyzing things it doesn't happen like that. So focus right now on the NX domain responses. You can go ahead and see, hey, it's malware is utilizing DGA, it's querying out there, it's sending out 3 from this host every hour. Okay, that's abnormal because we don't have that many in our environment per hour. Utilize your baseline and compare everything to, and compare and contrast what the responses you have are compared to what we're getting from a machine that's particularly effective. If you find a machine that has too many NX domain responses, analyze that. Is it a result of a bad finger like google.com with 3 O's? Okay, that's a common thing maybe, but a string of consonants and letters and numbers together is not particularly normal. So utilize your brain power there to analyze that information. And also, does it include suspicious domain names? And we'll talk about what particularly makes something suspicious to us or anomalous. Excuse me. Of the successfully resolved domains, are there any known malicious as well? So we just talked about where to find known malicious, utilize that resource to compare and contrast that to as well. All right, so what makes something anomalous or suspicious to you or your environment? Well, first thing we're going to talk about is domain name length. So typically, greater than 12 to 15 characters falls outside of what's normal for a second level domain name. Something that's memorable for somebody to memorize. Typically, it's within an 8 character range. So you can go like facebook.com, it's 8 characters. Google.com calls below 8 characters, right? So anything that's greater than that, when you're looking through a log, and you're doing a cursory look through all the sections of, let's say, your log list, and you start to streamline down through 8 characters, 10 characters, 12, all the way down through, and then you see something that's 15 or 33 in the example of Zeus, that's going to catch your eye, right? So focus on that as well. We also want to pay attention to character contents. So alphanumeric strings, as I already talked about, letters, numbers, just flowing together. That particular domain name, 2kjpdsf on down the line.com, is available because nobody wants it, because nobody can memorize that, right? So that's something that's going to be probably available to a malware author or somebody that wants to communicate to command and control cards. It's going to have command and control server ports, infected users to communicate to. So pay attention to that too. So typically these may not also fall outside of the range of what's normal with the content as well. So on a cursory look, this may look normal as well. So another thing to pay attention to is doppelganger domains. So this would be something like cnyahoo.com instead of cn.yahoo.com. So missing the dot between the subdomain and second level domain. Also misspelling. So an example there from Mandiant, and their ABT1 report is AOLonline.com, but one of those L is using a 1 instead of an L. So on a cursory look, when you're looking through a log, it may not stick out to you depending on the font that you're using. Also, double vowels or missing consonants. In this example, Facebook.com. So something that you may graze over, just like if you're looking through, task list and you see service hosts, you see a lot of service hosts or something like that, you may graze over the one that's actually malware. Oops. So, and also the thing to pay attention to is top level domains. Where am I connecting out to? .com, most likely all the time. Am I in America? Most likely .com. Am I in Europe? .eu, right? Or .co.uk if I'm in UK. We need to know where my top level domains I'm connecting out to. Do I have a business case for connecting out to .ru? Do I have a business case to connect out to .cn? Why are my users connecting out to that environment as well? So everything that you see there may be suspicious for your own unique environment. Are those top-level domains associated with hosting command and control servers? Are they known or notorious for InfoSec crime? And then also less common top-level domains such as .biz or .info. Those may not be bad, but I mean, let's be honest, everyone tries to use .com. So some tools that we're going to talk about to separate the bad information, or not bad information, but the information overload from what we need to look at here is going to be DNS top and passive DNS. The first one is DNS top. It can either be used as a live capture or it can feed in a PCAP file to it as well. It's only going to take in TCP information, so that's one little flaw from it. But what we can see here is on the far left side is the query sources. Who is querying out? We can also see who is querying out into where. The query source on the far right side, query source in the second level domain. Where are they going to and who is doing that query? We can also see the query types, which doesn't really fit in this category, and also in the middle there, the first level query names and second level query names. Another tool is called passive DNS. One benefit to this is it has a nice GUI. Sometimes you can't really stand looking at a terminal screen anymore. You need to look at a nice web page or something, a nice product. This has that added benefit. What we can do here is also search by, don't advance, specific type of records. A records, B records, C name, NX records, all that information you can do from like a data query. Also, we can do special reports there in that second column. NX domain specifically, like we were talking about. So what did not get resolved by network? I have this packet capture, either into the passive DNS. What did not make it out to the internet? One of my machines was trying to get it out there to the specific domain. I want to see all of those. And then also you can do advanced search as well. So you can do a logical AND. So you can do a specific known bad, fully qualified domain, such as evilmalware.com. Still advanced. Evilmalwaresite.com, and the answer at nxdomain.com. You can specify a specific date, so if you have intelligence from, let's say, a blog writer, you can go ahead and query inside of your specific environment for a specific timeline. Did I have any of this going out to this specific site on this date and time? Finally, we can go ahead and analyze the traffic of suspected hosts. What connections are those hosts making? Where have they gone past? If we see that they did make this connection to a bad site or tried to query out to a malware site, where did they go before that to get connected? So we need to go ahead and figure out where they went before as well. Excuse me. Has the C2 server been rotating through hosting infrastructure? So is it doing fast DNS, dynamic DNS, stuff like that? The IP address in question, where it's connecting out to ultimately, is it an IP address that's a server farm that's hosting legitimate websites? Is it hosting a legitimate website that has a business case that my users need to connect to? I can't block that IP address because I need my users to get out to that IP address for another for a legitimate business, so I can't just go ahead and do that. So we need to go ahead and set up some sort of black hole for that. And then ultimately, we need to go ahead, once you find this information, share it with the community, right? Defense is not sexy, offense is sexy, right? Hacking things is sexy, defense kind of blows, right? Right? It's really hard. It's much more fun to cause the mayhem than to find the mayhem, right? I know exactly what I want to do to your environment. I don't know what you've done to my environment. So share this information freely. If you have to do it anonymous, do it. If not, share it freely. I think that about wraps it up. I might have done my 15-minute time. If you have any questions, we have enough. No more time. I'm sorry. You can contact me here, or I'll be off stage, off to the side here, at hacknumber.com, facebook.com/hacknumber, or you can find me at the HFC booth or a product exploitation booth in the main lobby. Thank you for your time. I appreciate you guys coming out.